IPv4 addressing, Internet Protocol version 4, there are certain special blocks or special addresses. If we talk about classful addressing, these are all the addresses which are already saved, secured and blocked. So in the addressing scheme, IP addressing scheme, especially we are talking about Internet Protocol version 4. So this IPv4 is a 32-bit addressing. That means 2 to the power 32 addressing is possible. It is a dotted decimal, so it will start with 0.0.0.0. That is for every octet is 8-bit. 8-bit is 2 to the power 8. That is, it will start with 0 and go up to 255. See, 2 to the power 8, 256. So if you start with 0, it will go up to 255. So what is the maximum here? If it is lowest is 0, the maximum can be 255. So this is the last number. The first address possible is 0.0.0.0. The last address possible is 255.255.255.255. But there are certain scenarios which are being seen by the people, by the authority, with the governing body, and they reserve certain IPs for certain purpose. All 0 address, all 1 address, loopback address, private address, multicast address. So all these are called the special blocks of addresses. In IPv4 addressing, all 0 addresses. What does this stand for? IPv4 is a 32-bit addressing scheme. It is dotted decimal representation of the address of a computer. So we have the 8-bit, dot 8-bit, dot 8-bit, dot 8-bit form. 2 to the power 32 addressing is possible. The first address possible is, the lowest is 0. So 0.0.0.0. Now the first address, that is all the zeros, this address is called all 0 addresses. And this address has a special significance. So this is reserved, this is blocked. So all the zeros addresses, this is the first address in the IPv4 address space. So if we just write it in the CIDR form, it is /32. That means all the ones, all the zeros, not all the ones, all the zeros. Here 32 means all the zeros. So this is the first address space. So any host which is having this IP, which is all 0, is right now it is not connected to the TCP IP network. First thing is clear. Now, when a computer wants to connect to TCP IP, or you can say host wants to get connected to the internet, what it will do, it will send a packet to the IP service giver. What can be the IP address giver? It can be a bootstrap server, it can be a DHCP server. DHCP simply dynamically allots you an IP address, okay, whichever is available with it. That is the only work of DHCP, and you can call bootstrap server as the pre-form of DHCP. DHCP is based on bootstrap. Okay, so it just gives you IP address. So the packet will be sent by host to DHCP server. What will be the source address? The source address will be 0.0.0.0. Now when this packet goes to any DHCP server or bootstrap, and if it sees that the packet is coming with the source address as 0.0.0.0, that is the all 0 address, what will the IP address giver will do? What is the DHCP server is going to give? Because the packet is coming with the source address as 0.0.0.0 and the destination address is 255, 255, 255, 255. So when this kind of packet will come to the DHCP server, okay, this host can be computer, tablet or any other computing device. So the DHCP server, or simply the server which is giving the IP, it will assign the IP address to the host, and the host will then get connected to the internet. That is the whole scenario. That is a system or a host, all 0 address. In IPv4 addressing, this is a 32-bit addressing space which is represented by dotted decimal form. And all this dotted decimal, if you compute the number of zeros or ones, it will be 32. So the minimum possible is 0.0.0.0, and since the first octet, second octet, third octet, fourth octet, the maximum possible, because it is 8-bit, one octet is 8-bit, so 2 to the power 8, that is 256 is possible. So minimum is 0, maximum is 255. So if you have a block which is 255.255.255/32/32 is actually the CIDR. 255 is simply 8 ones. 8 ones, that is, this is the last address in IPv4 address space. 0.0.0.0 is the first one. Last one is this one. So this block or this all one address is actually the last address in the IPv4 scheme, addressing scheme. So there are two types of addressing, okay, IPv4, IPv6. We are talking about IPv4 here. So this kind of address where we have all the ones, it has a special meaning. It has a special significance. It is already say secured or blocked for certain purpose. So what is the purpose for this? The purpose is that all ones, as we just know that all zeros are basically to get the IP from the DHCP server. So this kind of address is called, this which we are talking right now is limited broadcast address. Now, why it is broadcast address? Broadcast address, that is a computer or a host uses this 255.255.255.255 all 32, that is all the ones, as a destination address in the IPv4 packet to broadcast message in the current network. If this is the destination address, that is all ones, in any packet, that means this packet has to be broadcast to everyone in the current network. Please understand, if there is a room, you come inside, there's plenty of people sitting. If you call, hello, all have to go for the lunch. So you are broadcasting it to everyone. So that packet will be broadcasted to everyone in the network. Plus, please remember, it is just the current network, not everywhere. Alright. So if the packet is containing all ones, that means it has to be broadcast in the current network. So this computer is sending the packet with the destination address as all one address. That means when it is coming, what will the router do? When it receives that kind of message with all ones, it will give it back, or it will broadcast it back to all the computer or the host in that network only, logical network only. It will not leave, this packet will not leave the local network. Okay? Broadcast, you understood that it will go to everyone in the network. But why it is called limited? This is limited because it limits that packet only into this local network. It will not go outside the network. So broadcasting, if you want to broadcast any packet, put the destination address as all ones, and that is already fixed. That is fixed in the IPv4 addressing scheme. Loopback address. In IPv4 addressing scheme, which is a 32-bit address scheme represented by a dotted decimal, you see here 127.0.0.1. So you might have used ping. I'm pretty sure in the command prompt you might have used certain command, for example ping. If you want to send packet to some system and you want it back, you do ping. Even if you in web browser, if you type 127.0.0.1, that also has a significance. So this 127.0.0.0, that is the whole block. /8 means the first 8 ones are fixed for the network address, others are for the host address. So 8-bit.8-bit.8-bit.8-bit total is 32-bit. So the first is, first possible is all zeros, the last one possible is all ones. This is the first and the last address of the address space of IPv4. But in between comes 127.0.0.0. Okay. And since in class full addressing, this particular address is of class A. So if you see here also 127.0.0.0 or any address with 127 as the first octet is the class A addressing. But 1 to 127 is class A. 127 after that it goes up to it goes up to 191. So class B, 192 to 223 is class C. So we have to concentrate only on the loopback address, which is actually 127. It starts with 127. So you can only use the class A addressing from 1 to 126. Why? Because anything with 127 in the first octet is reserved for the loopback addressing. So if you have used already 8-bit for this 127, how much is remaining? See, 8-bit you have already used for the network. So 2 to the power 32 minus 8 is for a host. So 2 to the power 24, that is 167777216 hosts are possible. Any network with the 127 as the first octet, the number of hosts possible is a huge number. Okay, 2 to the power 24, we compute like that, and you have to subtract 2 also from here. But just to make you understand that this is the whole number possible, these are the number of hosts. But out of this big number 167777216, loopback address only is 127.0.0.1. Okay, 127.0.0.1, this is used as the loopback address. Other 16777.215 are just wastage of this address. Okay, so in a classful addressing, as I just indicated you, this block 127 comes in the class A addressing, class A block, and all addresses which are starting with 127 point something are considered as the loopback address. So the loopback address can only be a destination address of a packet. So if you send your packet, if you want to send a packet with this loopback address, it will not go anywhere. You are speaking, you are listening. That is, loopback address is you are speaking and you are only listening. That means a packet with the loopback address will never leave the machine from which it is sent. It will go to the TCP IP stack of this machine, same machine, that is all the layers, and will be given back to the same machine. It will not even go outside your computer. It will remain inside your NIC card, network interface card, and will just check whether you are on the TCP IP stack or whether TCP IP stack is okay or not. So it can be used to check whether the NIC is network interface card, the network card you can call it, is properly functioning or not. Let me show you diagrammatically. This is how it works. So whenever you have 127 point anything, it can be 0.0, 0.1 most oftenly used. So this, if the TCP stack you want to check the network interfacing card working or not, then you can start a process that, like I just said, ping 127.0.0.1. So this packet will go to your NIC card, come back to your system only, to your application layer. Both application layer will be only your system. It will not go to any other system. So this is just to check whether your system NIC card is working or not. Private addresses. Now there are two things, public addresses and private addresses. Now you see on the left I have showed you the range of the private IP address. So the IPv4 addressing scheme is 32-bit addressing scheme, which is represented by dotted decimal, which you see here also. So what is this public and what is this private? See, this is your organization, this is your company, and you don't want to get connected to internet. So there will be a network in your company. So those network host or those computer laptop in your company has to be given certain IP. Alright. So these IP will only be from private IP address. When you want to get connected to the internet, then private IP cannot be used. It will always be public IP. On internet, public. On your organization, private. So private IP addresses are never used globally, never used on internet. It is only for your private purpose. So packet with the private IP addresses, that is from 10.0.0.0 to 10.255.255.255. Likewise, 2 more rows are there. So these all are private IP addresses are not routed on the internet or internetwork. It will always be in your personal network. So devices on the same network using the private IP addresses as configured by the network administrator, they will communicate through these private IP addressing space only. Okay. So if you are making a private addressing or organization addressing scheme, you need to choose from these 3 rows which I am highlighting here on the left top. Alright. Since you see 192.168.1.1 it is always used in your computer because it is a private IP. If you want to do the file servering or desktops and printering, you want to use printer, So this is how you need to communicate. You don't need internet for that. For that, your computers should be in these range of private IP because they are communicating privately. So in order to communicate with another network, for example, to an internet, what will happen? This private IP will be converted into the public IP. Okay? Private IP, this is the range which I am showing you here. It has to be converted to public IP, and that is done through NAT, which is Network Address Translation. So 192.168.1.1 till 1.4, I have showed you these are 4 computer, tablet, all the computing devices. Now it has to go to the internet or to another network. Then that has to be converted to some 82.1.29.80.111. This is the router converting the number into the numbers, IP addresses, which are understood by the other network or internet, which are the public IP. So private IP to public is done using NAT, Network Address Translation. Okay, but in your organization, it can only be private IP. The ranges are as shown here. What are multicast addresses in IPv4? What is multicasting? See, the most important thing you need to understand here is that in the classful addressing of IPv4, IPv4 is a 32-bit addressing scheme which is shown by dotted decimal number representation. So minimum can be 0.0.0.0 and the maximum can be 255.255.255.255. That is possible. Okay. Now in classful addressing, what happens? Every class is being devised or has some significance. So in classful addressing, the class A, B, C, D. Class D is reserved for multicasting. That is, this class D addresses are only for multicasting addresses. They are multicasting addresses. Class E is basically for research and experimental purpose. A, B, C we are using. We know already how do we use. So 1 to 127 and then 127 to 191. Then we have this 192 to it goes up to 223. Okay. So all these are the ranges of IP. But when we go above that 224. So when you talk about 224, then anything with 224 dot anything are the multicast addresses. So 224.0.0.0/4/4 means first 4 bits from the left are reserved for the network, others all are for the host. But we don't need any subnet mask here because this is multicasting. So number of addresses which are possible that are used for multicast is, because 4 you have already used for the network. How many are there for the host? 32 minus 4, that is 2 to the power 28. So how many number of addresses you can give or possible in your classful addressing of class D, which is 268435456, which is again a very huge number. Okay. So now this number is for the multicasting. This is a multicast address. So the multicast addresses are in the range from 224.0.0.0 till 239.255.255.255, because from 242 to 255, that is the first octet, 240 to 255 is E, class E, which is reserved for the experimental purpose. So this 224.4.0.0.0 and over that are multicast addresses. Now understand that you want to give an invitation to some people, but in your whole group you just want to invite some of them. So when you are inviting some of them, 2 of them you want to give the invitation card, 2 you don't want. So you are giving the invitation card as multicasting. So you are only giving to certain people, not everyone, not to no one. I hope you got the idea. Everyone is broadcasting. No one or only one is unicasting. But to some of them is the multicasting. So the multicast addresses is assigned to group of hosts instead of only one single host. Okay. So the packet sent to multicast address is delivered to all hosts of that group. So multicast IP routing protocols, these are employed, these are used to distribute the data. For example, the audio, the video, these are audio video streaming broadcast is done for multiple recipients. Okay, how do you see the IPL? How do you see the broadcast of FIFA World Cup? So using multicast, source can send single copy of data to single multicast address, which is then distributed to the entire group of recipients. Please understand, audio video means UDP. So multicasting is a UDP based. Okay, this all scenario or this concept is UDP based. All right. So let me show you diagrammatically also what is happening actually. This is a very simple multicast example. Now router A, this router A in this network sends a multicast packet which is received and processed by members of the multicast group. So here you see the yellow one. It is only going to host A and host D. So the host A and host D are only the multicast group member. So it is not going to host B or host C. Okay, so this is the multicast group, and that comes only with the multicasting address, which has to start from 224. All right. So this is multicasting or multicast addressing. So I hope you have a fair idea about special block of addresses in IPv4. Thank you so much. Take care of yourself.